Welcome to Mattermosaic, piecing together the universe one discovery at a time. Today, we're diving into one of the greatest achievements in human science, the periodic table, the chart that organizes the very building blocks of reality. Everything around you, the air you breathe, the screen you're watching, even the neurons firing in your brain, is made of elements. But how do we make sense of over 100 unique substances, each with its own behavior and personality? The answer lies in a single, elegant grid, the periodic table of elements. The story begins in the 19th century, when scientists were collecting new elements like explorers charting unknown lands. They knew that substances like oxygen, carbon, gold, and iron were fundamental, but they couldn't yet see how all these pieces fit together. Each new discovery deepened the mystery. Was there an underlying order, or were elements simply random? Then came a brilliant Russian chemist, Dmitri Mendeleev. In 1869, he took all the known elements, just 63 at the time, and arranged them not by name or color, but by atomic weight and chemical properties. To his astonishment, a pattern began to emerge. Similar elements fell into columns. Periodic repetition appeared across rows. And where there were gaps, Mendeleev boldly predicted that new elements must exist, ones not yet discovered. That was a revolutionary idea. Mendeleev's table was not just a catalog, it was a map of nature's design. He even left blank spaces where his table predicted missing elements, describing their properties in advance. Years later, when germanium, gallium, and scandium were discovered, they fit perfectly into his predictions. Mendeleev's insight transformed chemistry from a chaotic collection of facts into a coherent system governed by natural law. But the true key to the periodic pattern wouldn't be understood until decades later, with the discovery of the atom's internal structure. When scientists learned that each element is defined by its number of protons, its atomic number, the periodic law suddenly made perfect sense. The pattern wasn't arbitrary. It reflected the architecture of the atom itself. As you move across the table, from hydrogen to helium to lithium, the number of protons and electrons increases in a precise, rhythmic way. That rhythm creates recurring chemical behaviors, the reason sodium and potassium both react violently with water, or why helium and neon remain calm and unreactive. The periodic table became more than a chart. It became a blueprint for matter. Every column tells a story of shared behavior. Every row tells a story of progression, of atoms becoming more complex. It's like reading the music of the cosmos written in atomic notes. Look closely, and you'll see that this order extends far beyond the laboratory. Carbon, the sixth element, forms the backbone of life. Iron, at the heart of stars and blood alike, connects the universe to our very cells. Calcium builds bones, silicon builds planets, and hydrogen fuels the sun. The same table that explains fireworks also explains the chemistry of thought and life itself. Each box in the periodic table represents not just a chemical, but a chapter in the universe's autobiography. The table tells us how the cosmos built everything from stardust. It's the ultimate bridge between astronomy and chemistry, the language of elements forged in stars and organized by human reason. But the story doesn't end with Mendeleev. In the 20th century, new discoveries expanded the table beyond his wildest dreams. Scientists unlocked the secrets of radioactive elements, synthetic atoms, and the transuranic elements beyond uranium. Elements made in labs, fleeting but real. Each new addition stretched the limits of chemistry, physics, and imagination. Today, the table has 118 confirmed elements, and it may not be complete. Physicists predict an island of stability, a theoretical region of super-heavy elements that could exist beyond our current reach. Atoms that defy decay and challenge our understanding of matter itself. The search for these elements continues in high-energy laboratories around the world. But beyond science, the periodic table represents something deeply human, our drive to find order in chaos. It's a symbol of curiosity made visible, proof that the universe follows patterns discoverable by the human mind. What began as a puzzle of powders and gases became a grand unifying chart of everything that exists. In classrooms, labs, and even space missions, the periodic table is a reminder that knowledge builds on knowledge. Every discovery rests upon those who came before, from alchemists dreaming of transmutation to physicists mapping atomic orbitals. The table is their collective legacy, etched into every science textbook and glowing on every lab wall. When you look at the periodic table, you're not just seeing elements, you're seeing relationships, a network of laws that govern how matter interacts, bonds, and transforms. You're seeing how nature's complexity emerges from elegant simplicity, and you're also seeing a mirror of human thought, our ability to see patterns, make predictions, and decode the invisible. The periodic table is both a scientific achievement and a philosophical symbol, proof that the universe is intelligible and that intelligence itself is part of the same fabric. So the next time you see that grid of colored boxes, remember, it's not just a tool for chemists. It's a cosmic map. It shows how the same particles that form the stars form you. It's a bridge between the infinitesimal and the infinite, between matter and meaning. This is Mattermosaic, piecing together the universe, one discovery at a time. If you enjoyed this deep dive, let us know in the comments and keep the journey going by watching our next exploration into the hidden patterns that shape everything we are and everything we know.